Hey, welcome back. It is time for day 3 of Advent of Code 2022. So let's just get started. So day 3, rucksack reorganization. One elf has the important job of loading all the rucksacks with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packing instructions, and so a few items now need to be rearranged. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item per rucksack. The elves have made a list of all the items currently in each rucksack, which is your puzzle input, but they need your help finding the errors. Every item is identified by a single lowercase or uppercase letter, that is, lowercase a and uppercase a refer to different types of items. The list of items for each rucksack is given as characters, all in a single line. A given rucksack always has the same number of items in each of its 2 compartments, so the first half of the characters represent items in the first compartment, and the second half of the characters represent items in the second compartment. For example, suppose you have the following contents from 6 rucksacks. We can see that the first rucksack contains the items in... I lost my place. Right, okay. The first rucksack contains the items B, J, R, W, B, etc., like right here. Which means this first compartment contains the items from J up until R, right here. And the second compartment contains the rest here. And so on and so on. And then you can see that the only type that appears in both compartments is lowercase p. Right there. And right there. Yeah, same in the rest of them. So to help prioritize item rearrangement, each item can be converted to a priority. Lowercase items types A through Z have priorities 1 through 26, and uppercase items A through Z have priorities 27 through 52. In the above example, the priority of the item that appears in both the compartments of each rucksack is 16 for the lowercase p, 38 uppercase L, 42 uppercase p, so on and so on and so on, and the sum of these is 157. So find the item that appears in both compartments of each rucksack, and what is the sum of the priorities of these item types? All right, so this one is particularly easy to do in Python. Let me show you. Okay, so the first thing I did was I knew that I had to score them, and that was a pretty straightforward thing. So actually, for one of the very few times in my life, I wrote this test without even opening the file with my production code in it. So I knew that these were the edge cases, like lowercase a, lowercase z, uppercase a, uppercase z. If I got those right, I'd probably have everything right. So that was the first thing I did. And this is what it looks like. Make sure that I'm only looking at Python doesn't have so Python doesn't have a character type. It only has string types. So I would be passing in a string, but I wanted to make sure that it's only its length is just 1. Otherwise, I've done something else wrong, right? If I'm passing something in that isn't just a single character, something's up. And so I put it on assert so that I'll bail out if that happens. Python has a string module, and string has a constant called ASCII letters, which has all the letters in lowercase from A to Z, and then uppercase from A to Z. And it's actually in the order that we want. So get score is super easy too. We just return the position of the string or the character really that we got in, plus 0, because it's obviously the 0 indexed. And lowercase a was supposed to give 1. And that test passed pretty much immediately, I think, as soon as I got the off by 1. So this test is good. It works. Great. So the second thing we had to do was we needed to look at each line. Well, again, as usual, I put the sample text into one file, and then I created the tests. And the text of the challenge said that it was supposed to be 157 for the sample input. We have, so we load all the data, every line. We set the score to 0, and then for each line we create a comp1 and a comp2, which is each compartment. We index into it using, so there's no start index, and then the ending index for compartment 1 is the length of L, so the length of the line, and then we do integer division by 2. Otherwise, we would have we might have a fraction. So, and try to get like 10.0 elements out, and that's illegal. So the same thing for compartment 2. And then we have the whoopsie, like the one that the elf got wrong, which we get by turning compartment 1, the stuff that's in compartment 1, we turn that into a set. A set is a data type in Python that makes it really easy to perform set operations, obviously. Like intersections, unions, you can add, you can subtract, and so on and so on. So they are unordered collections of elements, unordered collections of unique elements. So if you try to add an element to a set that's already there, nothing happens. And yeah, the order is irrelevant as well, but you have all these really neat and convenient set operations. So you can do set, and then you find the intersection with the set of elements in compartment 2, and the puzzle description tells us that there's only going to be one element, so we don't have to even look at the length of it. We just pop that one element, get the score, add it up, and then we iterate through it, and boom, we're done. And yeah, it got us the right answer too. So cool. All right. Part 2. As you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item carried by all 3 elves. That is, if a group's badge is item type capital B, then all 3 elves will have the item type capital B somewhere in their rucksack, and at most 2 of the elves will be carrying any other item type. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All the badges need to be pulled out of the rucksack so the new authenticity stickers can be attached. Additionally, nobody wrote down which item corresponds to each group's badges. The only way to tell which item is the right one is by finding the one item type that's common between all 3 elves in each group. Each set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So, in the above example, the first group's rucksacks are the first 3 lines, Okay, and the second group's rucksacks are the next 3 lines. In the first group, the only item that appears in all 3 rucksacks is lowercase r. This must be their badge. In the second group, their badge item must be type Z, capital Z. Priorities for these items must still be found to organize the sticker attachment efforts. Here, they are 18, lowercase r, for the first group, 52, capital Z for the second group, and the sum of these is 70. Find the item type that corresponds to the badges of each 3-elf group. What is the sum of the priorities of those item types? So this is, in essence, the exact same thing as before, except we are finding the intersection between 3 sets. So everything that's in one elf's backpack, rucksack, and find the intersection with the other 2 elves in that same group, and boom, you're done. So 2 challenges, split it into groups of 3, and then find whatever is common across those 3. I am sure there are more streamlined ways to do this, but again, we get the data from the file. We start with score as 0. We set x, which is a counter, set it to 0, and we use that to index into the array of lines from the file. So start with 0, and then we do line 1, 2, and 3. We get that by, sorry about all those pop-ups. We get that with this index operation here. And then we increment by 3. Still call it a whoopsie because I just copied this line up here, who are we kidding? Did the same thing, created a set, and found the intersection with L2, and the outcome of that I used to find the intersection with line 3. And again, according to the puzzle description, that should be just a single line, or a single element, and we just trust that because why wouldn't we? Pop that element off, score it, add it to the total score, and you can just keep doing that until you are at the end, and that's it. You get the right answer. Yep, that was it. That's how I did this one. If anything wasn't clear, or feel free to leave a question or comment, or like and subscribe, I guess. Why not? All right, thanks. That's it for today. Bye.